Welcome to another video by Adeptis Academy. Have you ever looked up at a bird and wished you could soar through the sky? For centuries, humans have shared this dream. We told stories of flying heroes like Icarus, and visionaries like Leonardo da Vinci sketched flying machines inspired by birds and bats. Da Vinci's ornithopter never flew, but his ideas planted seeds for future inventors. Early pioneers built gliders, experimenting with wing shapes and materials, learning from every crash and success. Their persistence turned fantasy into science. Then, in 1903, Orville and Wilbur Wright made history at Kitty Hawk, North Carolina. Their first flight lasted just 12 seconds, but it proved powered. Controlled flight was possible. That short hop changed the world forever. The dream of flight became reality, thanks to centuries of curiosity and perseverance. Every airplane today is a tribute to those who refused to give up. The sky was no longer out of reach. How did we go from the Wright Flyer to today's giant jets? It's a journey of incredible ingenuity. Advancements in materials, aerodynamics, and engine technology have been revolutionary. Let's tour a modern airplane and explore the key components that make these aerial feats possible. The fuselage is the main body that houses passengers and cargo. It's designed to be strong, lightweight, and aerodynamic. Wings generate lift. Their curved upper surface and flatter lower surface create a pressure difference, allowing the plane to take flight. Ailerons and flaps are crucial control surfaces that allow pilots to maneuver the aircraft. Ailerons help the plane roll and turn. Flaps increase lift for takeoff and landing. The tail, or empennage, keeps the plane stable. The vertical stabilizer and rudder provide directional stability. Horizontal stabilizers with elevators control the aircraft's pitch. Engines provide the thrust to move the plane forward. They overcome drag and enable it to accelerate to takeoff speed and maintain flight. Together, these components work in perfect harmony to make flight possible. Modern airplanes are marvels of engineering. Next time you board, appreciate the incredible feat of engineering that's keeping you aloft. Flying isn't just about soaring through the air, it's a delicate balancing act, a constant negotiation with the laws of physics. It's about understanding and manipulating the forces that govern our movement through the sky. Between four invisible forces, the fundamental elements that dictate whether an aircraft stays aloft, climbs higher, or descends back to Earth. Lift, the upward force that defies gravity. Weight, the relentless pull of the Earth. Thrust, the forward momentum generated by powerful engines. And drag, the air resistance that constantly opposes our progress. Lift, generated by the shape of the wings and their interaction with the air, pulls the plane up, allowing it to overcome the Earth's gravitational pull. Weight, a constant and unwavering force, pulls it down, reminding us of our connection to the planet. Thrust, the power of the engines pushing against the air, moves it forward, enabling us to reach our destination. And drag, the invisible hand of air resistance, resists that motion, constantly challenging our speed and efficiency. For level flight, a state of equilibrium and balance, lift equals weight, a perfect counteraction of forces, and thrust equals drag, ensuring a constant speed and direction. Lift is created by the wings, carefully designed airfoils that manipulate airflow as they move through the air, generating a pressure difference that overcomes gravity, allowing the aircraft to defy its weight. Thrust comes from the engines, powerful machines that convert fuel into propulsive force, propelling the plane forward, overcoming inertia and air resistance. Drag is air resistance, a consequence of the aircraft's shape and speed, always trying to slow the plane down, a constant challenge to the engine's power. The pilot manages these forces, a skilled conductor orchestrating a symphony of physics with controls and engine power, making constant adjustments to maintain balance and direction. To take off, defying gravity and leaving the Earth behind, thrust and lift, working in harmony, must overcome, with a surge of power, drag and weight, the forces holding us back. To land, returning safely to the ground, the pilot reduces thrust and lift, carefully managing the descent, letting drag and weight, now allies in the landing process, bring the plane down gently, a controlled surrender to gravity. Every flight is a constant adjustment, a continuous series of calculations and corrections, keeping these forces in harmony, ensuring a smooth and safe journey. It's a dance of physics, a beautiful interplay of forces, guided by human skill, experience, and intuition. The sky is a stage, a vast and ever-changing canvas, and the airplane is the performer, executing a complex routine of maneuvers. Mastering these forces, understanding their interactions, is what makes flight possible, transforming a dream into reality. That's the secret behind, the fundamental principle underlying, every journey through the clouds, a testament to human ingenuity and our understanding of the natural world. How do wings create lift? It's all about their special shape, called an airfoil. The curved top and flatter bottom mean air moves faster over the top, creating lower pressure above the wing. Higher pressure below pushes the wing upward. This is lift, explained by Bernoulli's principle. Try blowing over a piece of paper. It rises, just like a wing in flight. The faster the plane moves, the more lift is generated. The angle of attack, the tilt of the wing, also matters. Tilting the wing up deflects air downward, and by Newton's law, the wing is pushed up. Both Bernoulli and Newton's principles work together to keep planes aloft. It's science, not magic, that lets a heavy airplane soar. That's the secret behind every takeoff. Lift keeps a plane up, but you need thrust to move forward and generate that lift. Propeller engines and jet engines both push air backward to propel the plane forward. Newton's third law in action. Propellers are spinning wings, pulling air from the front and pushing it back to create thrust. Jet engines suck in air, compress it, mix it with fuel, ignite it, and blast hot gases out the back for powerful thrust. Think of a balloon zipping around when you let it go. The air rushing out pushes it forward. Jet engines are a high-tech continuous version of that balloon. Thrust must overcome drag for the plane to accelerate. Once at speed, the wings can do their job and lift the plane. Engines are the muscle behind every takeoff. Without thrust, flight is impossible. While lift and thrust get us airborne, weight and drag are always pulling us back. Weight is gravity's pull on the plane, passengers, and cargo. Engineers use lightweight materials like aluminum and carbon fiber to keep planes strong but light. Drag is air resistance caused by the plane's shape and the friction of air moving over it. Parasite drag comes from anything sticking out: fuselage, landing gear, antennas. Induced drag is a byproduct of lift created by swirling air at the wingtips. Winglets at the tips help reduce this drag, making flight more efficient. Pilots and computers constantly adjust to balance these forces. During landing, flaps and spoilers increase drag to slow the plane safely. Managing weight and drag is key to safe, efficient flight. Every flight is a battle against gravity and air. How do pilots skillfully manage lift, weight, thrust, and drag? Let's explore takeoff, cruise, and landing, and how pilots orchestrate these forces to achieve controlled flight. For takeoff, maximum thrust overcomes inertia. The plane accelerates down the runway, building speed. At rotation speed, the pilot gently lifts the nose. This increases the angle of attack, generating lift to overcome weight and soar into the sky. Once airborne, the landing gear retracts to reduce drag. The plane climbs to its cruising altitude. At cruise altitude, lift balances weight, ensuring level flight. Thrust equals drag, maintaining speed. Thinner air reduces drag, improving fuel efficiency. Autopilot maintains the flight path, ensuring a smooth cruise. As the destination nears, the aircraft begins its descent. The pilot reduces thrust and lowers the nose. Drag and weight slow the plane. Flaps and slats are extended, providing lift at low speeds. Just before touchdown, the pilot executes a flare. This ensures a gentle touchdown. Spoilers, reverse thrust, and braking decelerate the aircraft. Each phase represents a balance of forces and pilot expertise. Aviation is full of surprising facts. Airplane windows are round, not square, to prevent cracks from forming at corners, a crucial safety feature. Cabin air is drier than most deserts, so drink water on long flights. It's also filtered with hospital-grade HEPA filters. Cabin lights are dimmed for takeoff and landing at night to help your eyes adjust in case of an emergency. Planes are designed to withstand lightning strikes. The metal body channels electricity safely around the cabin. Every detail, from windows to lighting, is engineered for safety and comfort. The science of flight is everywhere, even in the smallest details. From the Wright brothers' first flight to today's global air travel, aviation has transformed our world. It connects people, cultures, and ideas, making the world smaller and more accessible. The future of flight is focused on sustainability, electric planes, biofuels, and greener technology. Supersonic and even hypersonic jets could make travel faster than ever. Engineers are tackling challenges like noise and emissions to make flight better for the planet. The story of flight is about curiosity, innovation, and pushing boundaries. Every journey is built on centuries of dreaming and discovery. The sky is not the limit, it's just the beginning.